Welcome to the Unit 3 test review for Pre-Cal Trig Fall 2021. You can use this to review before you take your test, or if you've taken every attempt for your test and you need an additional attempt, you can use this to make revisions, to take notes, and to request a retake after you've made test corrections. So let's move on to question number 1. The question asked, what is the standard form of the equation of a circle whose diameter is 14 units and whose center is -4, 5? All right, I want you to think about where you want to start. What are the steps that we learned during class and in the course online to answer this question? You can use your notes during the test. So let's take something from our notes. We want to look at the equation of a circle in standard form. That equation is x minus h squared plus y minus k squared equals r squared, where h and k are the coordinates of the center of the circle. So h is -4 and k is 5. We have the diameter, we don't have the radius, but we can take half of the diameter to find the radius. So 14 divided by 2 is 7, so r is equal to 7. All right, now we're going to just take that and plug that into the equation of a circle. So we'll start with x minus h, and we said h is -4, so we're subtracting -4 squared plus y minus k, and k is 5, squared equal r squared. What is the length of the major axis of the ellipse? So we have the equation of an ellipse in standard form. We should easily be able to find h and k and pull out the center of our ellipse. So the center is 3, -4, because we're subtracting h and k. When you subtract a -4, it becomes a +4. A always follows x, so a squared is going to equal to 12, and b squared is going to equal to 24. Now we've got to determine what is the major axis. So if you need to pull out graph paper, we'll start with the center, 3, -4. We'll plot that, 1, 2, 3, -4, 1, 2, 3, 4. And just get an idea of where that longer axis is going to be. So if we look at, again, a squared is equal to 12, and we solve for a, take the square root of both sides, a is equal to positive or negative square root of 12. We can simplify that because 12 is 3 times 4, and we can take 4 is a perfect square. We can take that out from underneath the radical as 2, but that 3 needs to stay. So a is equal to positive or negative 2 square roots of 3. Okay, b squared is equal to 24. We'll do the same thing. We'll take the square root of both sides. So b is equal to positive or negative square root of 24. We can factor 24 into 6 times 4. And again, 4 is a perfect square. It's 2 times 2. Take that 2 out from underneath the radical. So b is equal to positive or negative 2 square roots of 6. All right, we can see that b is the larger number. B always goes with y, so our major axis is going to be parallel to the y-axis. So our ellipse is going to be elongated this direction. So we're going to start from 3, and the amount that we move up and down is 2 square roots of 6. Now for an approximation, you can take the square root of 6 times 2. I'm going to put that in my calculator, and it's approximately almost 5, not quite 5, 4.89 or 4.9. But anytime we take a square root, it's not an exact number, we get an approximation. The answer, or the question asks us, what is the length of the major axis? So we've determined that it's going to be longer going up and down, and that length of the semi-major axis is 2 square roots of 6. So if we have 2 of those, you can multiply 2 times 2 square roots of 6, or add these together, and you get 4 square roots of 6. So the length of the major axis is 4 square roots of 6. That's the entire length from here to here. It looks something like this. This is not an exact graph, but it gives me an idea of what I'm looking at. All right, how does the value of the eccentricity of the ellipse describe its shape? Now, the definition of eccentricity is how much a conic section, a circle, an ellipse, a parabola, or a hyperbola actually varies from being circular. All right, in this example, we're going to look at how flat or how round the shape of the ellipse is. The more flattened the ellipse is, the greater the value of its eccentricity. The more circular, the smaller the value, or closer to 0, is the eccentricity. So the eccentricity ranges between 1 and 0. So here we have a squared and b squared. Okay. If a is greater than b, then we calculate the eccentricity this way. E is equal to the square root of 1 minus b squared over a squared. All right, and we do have this condition. A is greater than b. So we'll go ahead and calculate the eccentricity in our example. So we want the square root of 1 minus 45 over 81. Can we simplify 45? Let me simplify this a little bit. 1 minus 45 over 81. Can we simplify 45 over 81? I think both of those are divisible by 9. 45 divided by 9 is 5, and 81 divided by 9 is 9. So we can rewrite this as 1 minus 5/9. Write 1 as 9/9. You want to keep these as fractions. Don't convert these to decimals, because you'll start running into error, and if you try to convert it back, it's going to be difficult to find your answer. 9 minus 5 is 4. So 1 minus 45 over 81 is 4/9. Now we want the square root of that. And 4 is a perfect square, so we can take that out from under the radical as 2. And 9 is a perfect square. Square root of 9 is 3. So this comes out as plus or minus 2/3. Okay, now you can take your calculator out and take 2 divided by 3, and we get 0.6 repeating. Now, is that greater than 1/2? Yes, it is. So that value indicates the ellipse is more flat than round. The center of a hyperbola is -4, 1. The length of the conjugate axis is 12 units, and the length of the transverse axis is 8 units. So I hope you've been practicing your vocabulary. All right, so the conjugate axis is 12. and the transverse axis is 8 units. The transverse axis is parallel to the y-axis. So this is what we know. We want to write the equation of the hyperbola in standard form. So the equation of the hyperbola is y minus 1 squared over 16. And the reason I'm starting with y is it tells us that the transverse axis is parallel to the y-axis. That's kind of, we can say that's like the major axis of an ellipse. Similar, not exactly the same. But whatever that transverse axis is, this variable, y, is going to come first, because now we have subtraction in between, not addition. Okay, now the y coordinate, we've got h and k for the center, and k is 1. So we put y minus 1 squared, and then the 16 comes from the transverse axis all the way, the entire length is 8. So half of that is 4. That's going to be our b. If we square that, if we square 4, we get 16. Okay, and that's what goes down here. Okay, now we go back and we put x. That's the conjugate axis. The conjugate axis is going to be the second, go in the second part after the minus right here in the equation. And x is negative 4 in our center. Our h is negative 4. So x minus negative 4 would be x plus 4 squared over. So the length of the conjugate axis is 12. Half of that is 6. So a is going to equal to 6, and a squared goes down here. 6 times 6 is 36. Okay, and that's going to equal to 1. So this is our equation of our hyperbola in standard form. Question number 5. What are the coordinates of the foci of the hyperbola? So let's start by identifying the center. The center of this hyperbola is, we start with the x minus h, so h is 6, and then y minus k. K is going to be a negative 12, because when we subtract a negative, we get a positive. So the center is 6, negative 12. All right, now we want to find the coordinates of the foci. So we need to find C, because C will give us the length from the center to each of the foci. Now we have a squared. Oops, the a goes with the x. So we have a squared is 16. B squared is 9. And our formula to find C is a squared plus b squared equals c squared. So 9 plus 16 is equal to c squared. Nine plus 16 is 25. 25 is equal to c squared. Take the square root of both sides, and c is equal to plus or minus 5. All right, now we're going to start with the y. Okay, we have a line that's parallel to the y-axis for this hyperbola. So we're going to change the y value by adding 5 and subtracting 5 to get where our foci are. The center is going to be, we've already identified that, at 6, -12. We're going to be going up and down parallel to the y-axis. So -12 plus 5 is going to be 6, and 7, 8, 9, 10, 11, 12, -7. Okay, and then -12 minus 5 is 12, 13, 14, 15, 16, 17, 6, -17. Foci 1 and foci 2. So the way that we do that, start with the center, identify a squared and b squared, a squared plus b squared equals c squared, find c, add or subtract that from the direction that the hyperbola is opening up in. It's opening up in the direction of the y-axis, so we change the y value. Question number 6. The general form of a parabola is x squared plus 9y squared minus 4x minus 36y minus 41 equals 0. You want to write the standard form of the parabola. So I'm going to start by taking all of the values that have an x variable in it. So that's x squared minus 4x. And I want to complete the square by adding a number so that I can factor it into two binomials squared. To complete the square, this coefficient needs to be 1. I cannot have more than 1x squared. And I do, so that condition is met. I'm going to go to the middle term. That's -4 divided by, by a positive 2 is a -2. And then we take that and we square it. -2 squared is positive 4. And we put that positive 4 right here. All right, now I'm going to factor this trinomial. Because I created the square, I can factor it out into x minus 2. That first number that we got when we divided by this middle coefficient. We divided -4 by 2, we got -2. And then we squared it and we added 4. So we can factor that into x minus 2 squared. Now over on the right, I have 0. So to 0, I added 4 to the left over here to these two terms. So I've got to add 4 to the right. Okay, now I'm going to move on. And I'm going to look at the terms that have a y in it. I've got positive 9y squared. And I've got minus 36y. And I want to do the same thing. I want to complete the square by adding something to this. All right, we cannot complete the square the way that we did previously with the x squared minus 4x until this coefficient is 1. So to get that into a 1, we've got to divide by 9. So I'm going to divide 9 by 9 and -36 by 9. And I'm left with 9. We factor that out. Times y squared minus -36 divided by 9 is -4. Don't forget your y. Okay, now I can complete the square. Now that I've got that 9 factored out. All right, take half of 4. It's going to be the exact same thing as what we did with our values that had an x in it. So divide -4 by 2, and you get a -2. Square -2 and add it in here. So we're adding in 4. So we factor the 9 out. This right here that we created, the perfect trinomial square, we can factor that into y minus 2 squared. Don't forget, we're multiplying. We took that 9 out. Now, in order to know what to add, what we added, we've got to multiply that 9 times that 4 inside the parentheses. 9 times 4 is 36. We're actually adding 36 to the left, so we're going to add 36 to the right over here. Now we've taken care of the first, second, third, fourth terms. We've used those to complete a square. We still have that constant -41. So I'm going to add 41 to the left, and I'm going to add 41 to the right. So I'll get my calculator out to make sure that I'm not making mistakes. 41 plus 4 plus 36 is equal to 81. So those three numbers added together are equal to 81. Over on the left, we've got x minus 2 squared, and then plus 9 times y minus 2 squared. We're almost there. We just have to have a 1 right here where the 81 is. So to get a 1, we divide by 81. If we divide this term by 81, we have to divide every term by 81. And then we'll simplify that. So let me change my pen color. All right, so we have x minus 2 squared over 81 plus 9 times y minus 2 squared over 81 equals 1. This is the standard form of the equation of the parabola. All right, for question number 7, we want to know what graph shows the circle whose equation is x minus 3 squared plus y plus 1 squared equals 9. All right, I'm going to start by pulling out the center. The center is going to be 3, -1. All right, so let's check these. Start at 0, 1, 2, 3, -1. The center is off, so that can't be the graph. All right, 1, 2, 3, -1. This can't be the graph. 1, 2, 3, -1. So this has the correct center. Now let's look at the radius and just double check. R squared, radius squared, is 9. You take the square root of that. And this is a length, so it has to be, we just consider the positive 3, not the -3. So is the radius 3 from the center to any point on the circle? 1, 2, 3. So yes, this is the graph of that circle. Question number 8. Fencing encloses a regular backyard that measures 200 feet by 600 feet. A blueprint of the backyard is drawn on the coordinate plane so that the rectangle has vertices 0, 0, 0, 30, 10, 30, and 10, 0. So you really need to pull out your graph paper and sketch this. If you don't have, I'm just going to do a sketch, so it's not important that you have graph paper, but it's more organized and easier to see if you do have graph paper. All right, let me get my pen. It keeps going back to my highlighter. All right, So I've got a coordinate plane, and the points that I'm going to graph are 0, 0, that's the origin, 0, 30, so I'm going to count in tens, 10, 20, 30, 0, 30, and 10, 30, 0, 0. Oh, hold on, I did that wrong. It's 30, 0. Here's 0, 0. 0, 30 would be 10, 20, 30 this direction. 0 in the x direction, 30 in the y direction. All right, and then I'm going to plot 10, 30. So I go over 10, up 30. And then 10, 0. Over 10, up 0. So we have a rectangle in this shape. Okay. A circular flower garden is dug to be exactly in the center of the backyard with a radius of 30 feet. All right, so I'm going to draw the diagonals, and those diagonals are going to be exactly in the center. So the midpoint of either one of those diagonals is going to tell me where the center of my circle is. All right, so I'm going to use the midpoint formula and just pick, I'll pick this diagonal, 0, 30, and that is 10, 0. Midpoint of these two coordinates, 0, 30. Second coordinate is 10, 0. I could have used these other two, as long as I'm getting one of the diagonals. All right, I'll call this x sub 1, y sub 1, x sub 2, y sub 2. And I'll use the midpoint formula, which we're basically adding the x coordinates. 0 plus 10 is 10, and dividing by 2. And then adding the y coordinates, 30 plus 0 is 30, and dividing by 2. And that will be our midpoint of the diagonal, but also the center of our circle. So 10 divided by 2 is 5, and 30 divided by 2 is 15. So this is our H, and this is our K. Now, this is going to be kind of small, but we're drawing a circle here in the center of the backyard with a radius of 30 feet. But this is a little bit, you really need to look at this, because this measures 200 by 600 feet. So it's 200 feet in this direction and 600 feet in this direction. So this 10 down here is not actually 10 feet, because we're 10 units we're comparing to 200. So we've got to divide by 10. Okay, so that this is actually, the radius is actually not 30. Divide by 10. The radius is 3. Okay. So now that we have the center and we have the radius, we can write the equation. Okay, we want the equation of the flower garden, which is that circle. So it's going to be x minus h, that's going to be 5, squared, plus y minus 15 squared equals 3 times 3 is 9. Okay, the hardest part of that was interpreting the measurement in feet and looking at our graph. Those 10 units didn't actually represent 10 feet in comparison to 20. For every 1 unit, that's 20 feet. So we're essentially having to divide our measurements by 10. The general form of an ellipse is 4x squared minus 9y squared plus 8x minus 36y plus 4 equals 0. And we want to put that into standard form. So I'm going to start by grouping together the terms that have an x variable in them. Then I'll order it from the highest power. That's going to be 4x squared plus 8x. And I'm going to add something to this to complete the square. Now in order to do that, the coefficient of the x squared needs to be 1, not 4. So to change that to 1, I'm going to divide by 4. If I divide the first term by 4, I need to divide the second term by 4. So what we're doing is we're factoring out a 4. Dividing both of those numbers by 4, pulling it out to the left, and then we have x squared plus 4 times 2 is 8, so we have 2x. And then we want to add something. I need to erase that parentheses, so hold on just a minute. So we're going to complete the square here, and we're going to add that number to the left side of this equation. To keep it balanced, we'll also add that number to the right side. Right, so we'll start by, we factored out the 4, so we have a 1 here. We go to the middle term and we divide that coefficient by 2. 2 divided by 2 is 1. And then we take that number and we square it and we put it here at the end. 1 squared is 1 times 1. So put that there. And then if we look at this trinomial and we factor it back out again, since I created it, I can factor it into x plus 1 squared. You can FOIL it out. First, outer, inner, last, just to check. And you should be able to get this. Don't forget we factored out that 4. Now, normally we would just say we added 1 to the left-hand side, so we'd add 1 over here. But we didn't just add 1. Since we factored that 4 out, if we distribute it back in, we'll get 4x squared plus 8x plus 4. So we're really adding in 4. To the left-hand side. So we need to add 4 to the right-hand side. So now I'm going to move on to the terms that have the y variable. Put those in order. 9y squared minus 36y plus, we need to figure out what we're adding here, and we're going to add it here. It's going to be a constant. We're going to look at this the same way we looked at completing the square with the x terms. We've got to make that first coefficient into a 1. So we need to divide this term by 9, divide this term by 9. So we're factoring out a 9. And we're left with y squared. 9 goes into 36 4 times, I believe. Let me double check that. Yep, and that's going to be 4y. Okay, plus, now we can work on completing the square, and we'll know what to put here. Okay, to complete the square, we take half of negative 4, which is negative 2, and we square that, and then we put that number here. Negative 2 squared is positive 4. Okay. So when I go ahead and distribute that 9 back in, I'll know what it is that I'm adding to this trinomial. 9 times y squared is 9y squared. 9 times negative 4 is negative 36. And 9 times 4 is just the number 36. So we're adding 36 to the left side of the equation. We need to add 36 to the right side of the equation. Okay, I still have this constant 4 right here. So we need to subtract 4 from both sides. So I'll subtract 4 from the left, subtract it from the right. So all we're left with is this, we took these values, completed the square, and then whatever we added to the left, we added to the right. So we can go ahead and factor those out. With the x's, I have 4 times x plus 1 squared. The y's, I have 9 times, and then we got this trinomial right here. Let me factor that back out again. Y, let me see, minus 2 squared equals, now all I have to do is add these numbers up. 4 plus 36 minus 4 is 36. Okay. Now, for the equation of an ellipse, we know that this number right here has to be a 1. So I'm going to change my pen color to try to keep it a little bit neater. Let's see if we can do that. All right, so I'm going to divide 36 by 36, and that'll put a 1 in that position. But if I divide if I divide any part of that equation by a number, I have to divide every term in that equation by 36. So let's take this first term and divide it by 36. The second factored term, divide it by 36, and I think that we'll have our equation. So on the right hand side, we'll see that this is 1. So we're good there. I'll just move backward. 9 goes into 9 once, and 9 goes into 36 4 times. So this part is going to be y minus 2 squared over 4. Okay. Let's move over here. 4 goes into 4 1, and 4 goes into 36 9 times. So we have x plus 1 squared over 9. And now if I look for that answer, I believe it's A. Let me double check. X plus 1 squared over 9 plus y minus 2 squared over 4 equals 1. So yes, that's the correct answer. For this question, we're asked, what is the center of the hyperbola? So we're going to first find where the x is. So don't forget to look here first. This should be in the form x minus h. So we'll just pull out the h. The center is going to be 10 for the x coordinate. And then we're going to move over here where the y is. And this should be in the form y minus k. Well, I don't see a minus. So k is going to need to be a negative 3, because when you subtract a negative 3, that becomes y plus 3. So we'll put that negative 3 right here. And this is the coordinate of the center of our circle. Don't forget the y is appearing first in this equation. So go here to find the x coordinate. That's probably the biggest mistake. For the next question, we're told that Clara grasped the hyperbola y plus 5 squared over 25 minus x plus 2 squared over 4 equals 1. So the first thing that she's going to do is identify the center of the circle. So think about the previous problem. We're going to go here first to identify the x coordinate. This is in the form x minus h. H is not a positive 2, x is a negative 2. Now we're going to move here to identify k. And again, k is not going to be a positive, it's going to be a negative. Negative 5. All right, now she's going to determine that the hyperbola opens up and down. Now the reason that we know that it opens up and down is because b squared, which is right here, and b always follows the y, b squared is greater than a squared. So it's going to run in the direction that the y-axis runs, up and down. All right, now we have a squared is equal to 4, so a is equal to plus or minus 2. And b squared is equal to 25, so take the square root of 25 and you'll find b is equal to positive or negative 5. All right, because it's going up and down, we're going to go from the center, positive 5 and negative 5, to find the vertices. So the first vertex, we're not going to do anything with that x-coordinate, but we're going to take the y-coordinate, negative 5, and we're going to add 5 to it. So we get negative 2, 0. And the second vertex is, now we're going to subtract 5 from negative 5. Leave the x-coordinate alone. Negative 5 plus negative 5 is negative 10. Okay. Now the equation for this, or the slope of the asymptotes, is going to be positive or negative b over a. So it's going to be 5 over 2, positive or negative 5 over 2. And the equation is written this way. We take the y plus 5 is equal to positive or negative 5/2 slope times, now we're going to take this part of the equation, x plus 2. Okay, that's it. You can write this as two different equations, but I just wrote it all together by putting this plus or minus right here. The next question, we have the endpoints of a diameter of a circle. We're given that they're negative 1. I'll label that x sub 1, y sub 1. And then our next point, endpoint, we'll label x sub 2 and y sub 2. We'll use the distance formula to find the distance of that diameter. So the distance equals to the square root of x sub 2, which is negative 3, minus x sub 1, minus 1, squared, plus y sub 2, which is 4, minus y sub 1, and that's 4, squared. So let's work on simplifying that. Distance is equal to the square root of negative 3 plus a negative 1 is a negative 4 squared, and then 4 minus 4 is 0. Okay, so the distance is equal to the square root of 16. This is 16. 16 plus 0 is just 16. So the distance is equal to, distance is always going to be positive, so I'm just going to take the positive 4, not the negative 4. So the distance between these 2 points is 4 units. That's the diameter. I need to find the radius. The radius is going to be half the diameter, so I'll take that 4 and divide it by 2. The distance of the radius is 2 units. All right, now the standard form of the equation of a circle is x minus h squared plus y minus k squared equals r squared. Now we have r is 2, So we can plug that in here. Now we need to find the center, h and k. Now the center, we're going to take these same 2 points, but we're going to use the midpoint formula, and the point that's right in the middle will be our center. So the midpoint formula says to add the x coordinates, 1 and negative 3, divide by 2, add your y coordinates, 4 plus 4, and divide by 2. So the midpoint is going to be negative 3 plus 1 is negative 2, divided by 2 is a negative 1. 4 plus 4 is 8, divided by 2 is 4. So now this is our h and our k. We can go ahead and substitute that into our formula. X minus negative 1 squared plus y minus 4 squared equals 2 squared. We change this minus a negative to plus a positive. So we have x plus 1 squared plus y minus 4 squared equals 4. This is the equation of a circle written in standard form. Okay, so here we have the vertex of a parabola is 6, 3, and the equation of its directrix is y equals 5. So I'm going to start by kind of sketching this out to see how this parabola is oriented. So the vertex is going to be at 6, 1, 2, 3, 4, 5, 6, 3, 1, 2, 3. Six, 3. And the equation of its directrix is y equals 5. So I'm going to go up 2 more and draw a dashed line for the directrix. So you can see the directrix is 2 units away from the vertex. So P is equal to 2. And it's going to be pointing down. I'm just kind of sketching this in. All right, and if we go down 2 more units this way, we'll find the focus. All right, because it's pointing down, P is going to be negative. Okay, so instead of positive 2, P is equal to negative 2. We're starting at the directrix and we're going down. All right, so the equation, we're going to take h and k here, plug it into the equation for a parabola. X minus h squared equals 4 times p times y minus k, and k is 3, squared. Substitute that negative 2 in here for p. Multiply negative 2 times 4 and you'll get negative 8. And simplify this just a little bit more. And here's our equation. X minus 6 squared equals negative 8 times y minus 3 squared. Oops, I'm sorry, that's not a squared over here on the right. That's just y minus 3. I need to not be so tired when I do this. There we go. That's the equation of our parabola. Okay, so for question 14, we have the center of an ellipse at 2, 3. And the focus is at -4, 3. So I'm going to sketch that. Just make a quick graph. Just kind of see what's happening. All right, the center is at 2, 3. One, 2, 1, 2, 3. Okay, and one of the foci is at -4, 1, 2, 3. Oops, wrong direction, going in the y direction. 1, 2, 3, 4, 1, 2, 3. All right, one vertex is at 8, 3. 1, 2, 3, 4, 5, 6, 7, 8, 3. All right, from the center to the vertex we're at 2, 3. We're going to move over 6 units. 1, 2, 3, 4, 5, 6. So A is equal to 6. We go 6 units in this direction. 1, 2, 3, 4, 5, 6. So for question 14, we have the center of an ellipse at 1, 6. One focus of the ellipse is -2, 6. One vertex of the ellipse is 10, 6. What is the equation of the ellipse in standard form? So what I'm going to do is I'm going to sketch out, just kind of give myself a quick idea of what's happening here. Okay. It looks like we're going to go -2 in the x direction. Most of it's going to be over the other side. Okay, so I have a center at 1, 1, 2, 3, 4, 5, 6. We're up here. Okay. And we have a focus at -2, 6. Oops, I didn't draw that high enough. There we go. Alright, if you count from the center, that's 1, 2, 3 units. From the center to the focus. So that's going to be C. C is 3. Alright, we also know that one vertex is at 10. So we're going to go over here 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you look, the X is changing. To go from 1 to 10, we travel 9 units. So the distance from here to here is 9. Okay, remember that A follows X, and we're going in the X direction. So A is equal to 9. Okay, we have the center, we have H and K. The only thing that we don't have is B. Alright, B squared is equal to A squared minus C squared. So A squared is 9 times 9. 9 times 9 is 81. C squared is equal to 3 times 3. 3 times 3 is 9. Okay, so B squared is equal to 81 minus 9. And I'll get my calculator out just to double check. 81 minus 9 is 72. So B squared equals 72. So now we have everything that we need to plug into our equation. Right, the equation is x minus h and h is 1 squared over a squared. A squared is 81 plus y minus k. K is 6 squared over b squared. B squared is 72 equals 1. So this is our equation for our ellipse. For question 15, we're given a system of conics, and we're told that it has two solutions. So we're going to look at this and use our algebra to solve. And there are different approaches, so I'll just show you the way that I approached it. All right, let me see here. I'm looking, and I'm just going to pick out this y minus 3 and y minus 3 squared. Those are the same things. So I'm going to solve for y minus 3 squared in this first equation by subtracting this x minus 2 squared from both sides. Okay. So now that I've subtracted it from the left and from the right, I just have y minus 3 squared equals 16 minus x minus 2 squared. So I can substitute this in for y minus 3 squared. I'm going to substitute it in here. So in the bottom equation, I have x minus 2 squared over 16 plus, now here's where I'm going to substitute 16 minus x minus 2 squared over 64 equals 1. Alright, now what I want to do is, again, there's different approaches, but this is just what I would do. I'm going to multiply every term by 64 on the left and on the right. So 16 goes into 64 4 times. So we get rid of that denominator there, and we're left with 4 times x minus 2 squared plus 64 goes into 64 1 time, so that's gone, and we have 16 minus x minus 2 squared equal, and then 64 times 1 is 64. Alright, let me get another pen color here. I'm going to go ahead and foil that out. I'm going to go back up to the top left. And I have 4 times x squared. We have a negative 2x and another negative 2x. That's negative 4x. And then the last term is going to be negative 2 times negative 2, and that's positive 4. Plus, that's just this part right here, 16 minus x minus 2 squared. Now we've already foiled that out here, so I know what that is. 16 minus x squared minus 4x plus 4 equals, we still have that 64 over on the right. Right, and go ahead and distribute that 4 in. 4 times x squared is 4x squared. 4 times a negative 4 is a negative 16x. 4 times positive 4 is positive 16. And then we have plus 16. Keep going. And then distribute that negative 1 inside the parentheses. So that makes that minus x squared plus 4x minus 4 equals 64. Now combine like terms. Positive 4x squared minus x squared is 3x squared. Negative 16x plus a positive 4x is negative 12x. And then positive 16 plus a positive 16 is positive 32 minus 4. Let me get my calculator out here. I'm just double checking to make sure I did that last part right. Negative 16x plus 4x to negative 12x. Okay, I did that right. Okay, 16 plus 16 is 32 minus 4 is 28. We still have that 64 on the right, so I'm going to subtract that from both sides. Pull that down a little bit, so that leaves us 0 on the right. And on the left, I'm going to factor a 3 out of all 3 of these terms. They're all divisible by 3. And 64, negative 64 plus 28. Oh, I better do that. And then I get a negative 36, which is also divisible by 3. So factor a 3 out of 3x squared, and you're left with x squared. 3 goes into 12 4 times, so minus 4x. And 3 goes into negative 36 negative 12 times. Alright, now I'm going to factor this trinomial. I'm going to look at the factors of negative 12 that add to a negative 4. And the only thing I could think that would work would be 2 and 6. If I make the 6 negative, 2 times negative 6 is negative 12, which is what I'm looking for. And then 2 plus a negative 6 is a negative 4. So this factors into 3 times x plus 2 times x minus 6 equals 0. Now setting 3 equal to 0, that's not going to make much sense, but I can set this equal to 0 because if x plus 2 equals 0, then the whole thing is 0. That makes a true statement. So set x plus 2 equal to 0 and solve for x. X will equal to a negative 2. And set x minus 6 equal to 0. X will equal to 6. Now those are the possible x coordinates. So I'm running out of room here. But basically, and I've written over my equations, basically you pick one of these, substitute in negative 2 for x. And when you substitute in negative 2 for x, and you solve for y, then you get y equals 3. Also, if you substitute in here, let x be 6, plug that into one of your equations, solve for y, and you'll get y equals 3. So these are your two solutions. All right, thanks for watching. I hope this helps.